Question 5. Two vehicles, A and B, travel along the same straight highway. Vehicle A moves at a constant speed of 5.0 meters per second. Vehicle B starts 200 meters behind A with an initial speed of 2.0 meters per second and a uniform acceleration of 0.40 meters per second squared. After how much time will Vehicle B catch up with Vehicle A? Now this problem tests our understanding of kinematics, particularly how to compare the positions of two objects moving with different types of motion. So let us begin by recalling what we already know. We know that constant velocity motion can be described by the equation displacement equals velocity multiplied by time. Uniformly accelerated motion can be described by the equation displacement equals initial position plus initial velocity multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. In catch-up problems, the key idea is that the two objects meet when their positions become equal, so we equate the positions of the two moving objects. Now let us work through the solution. First, we describe the motion of Vehicle A. Vehicle A moves at constant speed, so its displacement is given by speed multiplied by time. Vehicle A moves with a speed of 5.0 meters per second. So, the displacement of A equals 5 multiplied by t. Next, we describe the motion of Vehicle B. The general equation for uniformly accelerated motion is displacement equals initial position plus initial velocity multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. Vehicle B begins 200 meters behind A, so its initial position is 200 meters. Its initial speed is 2.0 meters per second, and its acceleration is 0.40 meters per second squared. Substituting these values gives displacement of B equals 200 plus 2t plus 1/2 multiplied by 0.40 multiplied by t squared. Since 1/2 multiplied by 0.40 equals 0.20, this becomes displacement of B equals 200 plus 2t plus 0.2t squared. Now we apply the catch-up condition. Vehicle B catches Vehicle A when their displacements are equal. So we set 5t equals 200 plus 2t plus 0.2t squared. Next, we rearrange the equation 5t minus 2t minus 0.2t squared minus 200 equals 0. This simplifies to negative 0.2t squared plus 3t minus 200 equals 0. Solving this quadratic equation gives two solutions for time, 40 seconds and negative 25 seconds. Since time cannot be negative in this situation, we discard the negative value. Therefore, Vehicle B catches Vehicle A after 40 seconds. This is our final answer. What did we do? We first wrote separate equations describing the motion of each vehicle. Then we used the idea that the vehicles meet when their positions are the same. After equating the two displacement equations, we solved the quadratic equation and selected the physically meaningful positive time. Now let us summarize. Catch-up problems depend on comparing how far each object has traveled from the same reference point, and are solved by equating the positions of the objects involved. When the two displacements become equal, the overtaking occurs. We saw that acceleration gradually increases speed, allowing a slower starting object to eventually close the gap. So, Vehicle B catches Vehicle A after 40 seconds,